In this video, we're going to look at higher order functions, and the kind of a textbook definition for higher order functions is when a function takes in as a parameter a function, or when a function returns as a value that happens to be another function. This function in question is basically higher order functions. And just as typical many functional programming ideas, functions are considered as first-class citizens, they're considered as values, and this is what facilitates in a function taking a function as a parameter, or a function returning a function as a value. So in that spirit, what we're going to do right now is we're going to look at some kind of some simple, some trivial ideas with these higher order functions. So let's get started here. And the first thing I'm going to do is I'm just going to get rid of things that I don't require on this screen here. So let's get rid of the earlier code from the last video, and let's create a function. Let's create a function called apply that takes in as a parameter. It takes in as a parameter another function, and let's call this as transform. You can just call this function transform, and it takes in a second parameter, which is basically in this case let's say y. And simply what apply does it just takes transforms and applies it on y, meaning this is going to be transform y. Okay, so let's first again look at it a little bit more formally. So apply is basically a function of two variables. Okay, so think of apply as a function. It takes in an f, some another function, and it takes in a second parameter, which is a y, and it simply gives you back as a return value whatever is f of y. Okay, so this is how typically you would write this in math, where apply is a function of two parameters. Okay, the first parameter happens to be a function, some kind of a function. Okay, it could be any function, doesn't matter. All we know is that it's a function of one variable. There's a function of one variable, so I can see that in this case y gets applied directly to f, and this is the second argument into my function apply, and this is what apply simply does. It just returns back the value of f of y. Okay, so what would the functional type for apply look like? The functional type for apply, so if I would kind of write this a little bit formally, so again I'm using kind of my Haskell's notation there, but that's okay. So the functional type for apply is basically applies a function that takes in as a parameter, in this case that f there, but f again in turn is this function that takes in this whatever this y is and returns back to you whatever is the output. So it's a function that goes from, let's say, a to b. Okay, now I'm doing this because there's no class constraints or any constraints right now on a and b. I could do that. I could make a and b as integers, but let's just try to be a little abstract at this time. So this is basically what a function f is. It's a function that goes from a to b. Okay, the second argument here is basically a y, and this y over here, well, the y could be any value, but again the constraint on y, well, implicitly that's implied, is that the value of y must be of type a there. So this is going to be of type a, and the return value for apply is going to be, well, whatever is f of y, right? And what is f of y? What is the value of f of y? Well, the value of f of y is basically this b there, right? Because this b is the value, the type of the value that is returned back from this function. And this function over here in question is the function f. So this is going to be b there. Okay, and so this is basically what apply looks like. And let's just try this out. And see what f# gives me back. So if I go back to my thing here, and f#, and if I compile and run this code here, I can see something very similar from f#, where I can see that the function type for apply is basically this. It takes in as a first parameter a function that goes from a to b, and the second argument here is this a, which happens to be the a value some kind of a value that has a type, in this case prime A, and the return value in this case is going to be prime B, which is the value that you get back from the function y. So giving this definition to F sharp, this is the inference, this is the type inference that got sent back to me. And so what are some of the things I can do with this? So let's say if I go back to my function apply, and if I say, okay, let's call apply, let's call apply by apply requires this function that goes from an A to a B. What kind of a function do I have that goes from an A to a B? Well, if you remember from the last video, I already had a function that went from an A to a B, which was an increment. An increment was really simple, it just incremented a value. So let's just pass in an increment function, and I'm going to pass in a second parameter, let's say in this case a 7. Okay, and what's the idea? What do you think this is going to give you back? Well, this is going to give you back whatever is increment of y. So this is going to be increment of 7. So this is going to give you back a value, in this case a value of 8. Okay, so can I try this out in F sharp here? So let's come back over here. Let's just quickly define a function from last video, which was addition of xy equals to x plus y, and then I had a function increment that was simply addition of 1. Okay, and let's just run this. Let's just make sure our type inferences have all been input correctly. That seems good. And now I'm going to say let some value, let's say x in this case, going to be apply, and apply takes in the first parameter, some kind of a function. So I'm going to pass in this case increment inc, and I'm going to pass in a second parameter, in this case some kind of an integer. So this is going to be, let's say 7. So I'm hoping that in this case x equals to 8. So if I run this, I can see that x is equal to 8. I can even change this. When I'm going to say, okay, look, I don't want to, what if I do this? What if I say let z equals to apply, and let's just pass in this function, because as I said, in Haskell and in F sharp, every function can be interpreted, at least from purity, from every pure function, it can be considered as every function takes in one parameter. So I already have that function that takes in one parameter, which is an addition there. So I'm going to say let apply addition, and I'm going to pass in, let's say in this case, some kind of a value which is 7. Now think for a second, what do you think the value for z is going to be? Or more importantly, what is the type of z going to be in this case? So let's try to, before running this, let's try to get some intuition. So again, apply is basically has a signature where the first parameter is a function from A to B. The second parameter is basically a value of type A, and the output from this is going to be some value of type B. That's basically the definition of what apply is. Okay, now how am I calling apply? Well, I'm calling apply over here. I'm calling apply by, so you can see the definition for apply right here. I'm calling apply now by passing in the first parameter, an addition, and the second parameter over here, a 7. Okay, so what is this going to be equal to? What is this going to be equal to? So I can see that if apply in this case takes in addition, this addition in turn is a function that basically takes in an integer, goes to, let me just use a slightly different color here. Let's just use slightly different color. So an addition is basically a function that goes from an integer to an integer to an integer, and by using function curring, this can be interpreted as a function takes an integer, in turn gives you back a function that goes from an integer to an integer. Okay, and so in this case, A is basically in this case, A maps to this integer, and whatever this B is, well, this B maps from an integer to an integer. I'm just going to try to get this one-to-one mapping there. Okay, so what's the second parameter? The second parameter needs to be A in my function apply, where this A in this case happens to be some value of type integer that happens to be a 7 there. So what's B going to be? Well, B is going to be now a function. B is going to be a function that goes basically from an integer to an integer. So in this case, z that's in question, this z that I'm thinking about or that I had referred to earlier is basically not going to be an actual integer. It's going to be a function that goes from an integer to an integer. So what kind of a function is z? If I apply the definition, I can simply see that when I apply the definition of apply, I'm going to see addition, where transform is now equal to addition, and then I'm going to pass in the parameter y, so addition with 7, and addition with 7 is going to give you back a function, that goes from an integer to an integer. Okay, and that's what basically the function z is going to be. So let's just see this. So if I come back over here and if I run this, I got my z as a function goes from integer to integer. And now if I say let x, in this case let's say z1, let z1 equals to z with, I'm passing 8 here, is simply going to take 8 added to 7, which is going to be 15. So z1 is going to contain the value 15. Okay, so again, this might seem a little bit convoluted early on, it might seem a little bit confusing early on, but this is one such example where we can see where you're passing a function as a parameter to another function. And so we're going to look at a few more examples. Actually, I'm going to look at one more quick example a little bit later, maybe in my next video, to really connect some of these ideas with higher functions a little bit more explicitly. So yeah, see you again in the next video.